Hey everybody, Dirk here. Welcome once again to the Dungeon Laboratory. Just want to, make a video, show you guys what I've been kind of messing around with. I got Tesla coil fever, I tell you. I got my Mega Slayer exciter over here, working again. It's basically 4 transistors on here. They're all in parallel right now. I do plan on making like a 3 or 4. Or basically a multi-primary, probably for this coil, the secondary in particular. Yeah, one thing to note with the transistors is to put a resistor for each emitter if you're going to put these in parallel. These act as a balance for the transistors. I did have one die on me. That's only because I cranked it up to like 80 volts. Essentially, these are like television line output transistors for the flyback, and they're like, I think like 700 volts at like 7 or 8 amps or something like that. Problem is, even with these balancing resistors in here, one is gonna heat up more than the other ones. At least that's what it seemed like. So yeah, I'm gonna say about 60 to 70 volts is the max for this, but that's more than enough for such a simple circuit. It's pretty cool. It puts out a lot of RF energy. I think it's pretty awesome. What else we got? We got this. I'm going to test this out. This is one of those CD40 46 PLL chips. I'm just going to have this on a single, just running a single MOSFET right now to run this little coil over here, which goes over to my Class E setup that's over there. It's basically the same. It's basically the same circuit. So I'll get that up and running. Probably make another a separate video. I'm going to include 2 Tesla coils currently, and then this one will be later. And then I have my little tube set up here, my little miniature one. Unfortunately, I really wanted to put it into this. If I can get it out without pulling out a bunch of paperwork, into this box. It's one of those HEX supplies. Like that one over there. It's basically the metal housing, and it was really rusty, so I went ahead and cleaned it all up and gave it a couple coats of some blue spray paint. Those marks were obviously not there. That's where the coil and the tube were sitting on top, pretty much in here, and then all the other components were inside. And I went through about 10 fuses trying to get this to go. It would not work in the box for some reason. I could take it apart and have all the guts running the circuitry, and then have the top portion with the coil and the tube on the side, and everything would work fine. I put it all back together, and it wouldn't work. I tried everything. I tried isolating everything, all the switches. You can see there's a couple switches there, potentiometer, everything. I had this box originally earth grounded. The coil has its own separate ground, and I even disconnected that, and that didn't work either. It just kept blowing the fuse, and I have no idea why. It's really weird. So unfortunately, I had to go the wood route, and it doesn't look so great, but at least it works. I do plan on making a different type of coil. I think a coil of similar height with double the turns probably give me a little bit more output than what I'm getting right now. But, it's a little tabletop Tesla coil. It's nothing fancy. So what I'll do is I'll get this running over here. I'll just show you guys really quick because I got it going again. And then I'll tack on the video on the end having this running because I need to hook this up to the RF ground, and my ground connection is not too long, and I don't want it running all over this stuff. So yeah, we'll just get this going really quick. See if I can put you guys right there. I might bring you up. So I'll get everything kind of set up here. Yeah, this puts out quite a good amount of power. And that's basically nothing. Oops, you can't really see, can you? Alright, Yeah, sorry about that. I pressed some button on my damn camera. I was trying to push it up. Let's see if we can do that again. My apologies. Yeah, we'll get that like that. I think that'll be all right. Turn this back up again. It's not very much power at all. There's no actual output. Discharge, that is. But that's running pretty damn good. I gotta be careful holding this when it's like really putting out power, because I can actually feel the It's actually not that much power going through there. It's probably about 12. I don't know, 12 volts, something like that. A little bit more. There's actually a little bit of power coming out of there. I guess we can just crank it up all the way. Under that tube is lighting up. I don't like running it too long because I constantly check these transistors. It seems like this one gets the hottest, the quickest. I want to get a fan on there. Yeah, but basically what it is one of the transistors starts heating up more than the other ones. Obviously, the resistor is going to start heating up. It's something that has to do with like a negative feedback to where, yeah, it cools off due to this balancing resistor that's on here, and that's what they are. You can read about it online. That's how I figured it out. Because I put these on before, and I forgot what the purpose of these was, so I had to look it up again. But yeah, I mean, you can. Yeah, I'll crank it up again, but you can see this. That's pretty damn good. That's a massive amount of power. I really wanted to try to interrupt this somehow, but I can't figure out any practical way of doing it. Considering that this coil is actually going onto the circuit itself. I tried everything, so if anybody else out there has a suggestion, or they got something to work on here as far as an interrupter circuit, I don't care what it is, as long as it works. That's the main part. I like I said, I tried doing everything. I even tried using optocouplers to isolate the actual interrupter circuit, because basically what was happening was I was turning this on, and the interrupter circuit would just cease to function. It would just stay on, or it wouldn't come on at all. And I think it has to do with the feedback from the secondary coming through the circuit. So yeah, if anybody has any other suggestions, I'm all ears. I would love to get this interrupted, because that's pretty good output. Like, about that. A couple centimeters tall, even more. If I crank it up to 60, 70 volts, it's even more. And I would love to interrupt this. That'd be really, really cool. So that's pretty powerful, I think, for that type of simple circuit. Just using standard components. Nothing spectacular. But yeah, pretty cool. So I'll get the tube coil set up, and we can kind of go through that a little bit. And yeah, so we'll see you guys in a bit. What's going on, fellas? Dirk here. Welcome once again to the Dungeon Laboratory. I'm going to tack this on to my Mega Slayer video, as opposed to the tube circuit over there. I got to fine tune it somehow. I need to get the primary and the feedback just right. It keeps blowing fuses for some reason. It's a really fussy circuit, so that kind of put me off a little bit. So I figured I'd show this instead. I've been kind of messing around with this and tinkering with this. This is basically a Class C or Class E Tesla coils, solid state, which utilizes one of those CD4046 ICs. So there's no feedback or anything on here. And what else would I've done? Because normally on that actual kit that I bought, the secondary goes into the negative, and I have this one going off to my own separate RF ground, and it works. Me being dumb, it uses a push-pull set of transistors, and I kind of got that a little backwards, so I went ahead and corrected that. It's a bit weird how this works, but I don't know a whole lot about these ICs just yet. I do want to build some other things eventually here. So anyway, yeah, this works pretty damn good. Go ahead and crank it up a little bit. That's only 7 volts, and it's already oscillating. That's not bad. This circuit is, let's see here, it's between 1 and 1.3 megs, which I'm going to assume this coil is. And I'm about the halfway mark, so I'm going to say it's about 1.1, 1.2. I'll have to put the frequency counter on there and see what that's actually running at. But it's pretty nice. It'll even light up this fluorescent tube back here. So then we got 12 volts, and that's sliding up pretty nice. Oh, there we go. Oh yeah, get a little output. That's at 18 volts. Not bad. I'll shut the light off here. Here we go. And that's going. I'm just using an IRF P260N, I believe. I'll crank that up just a little bit more. So that's the normal operating mode, 24 volt input. You can go up to about 35, I think, or 30 on that one. But the problem is that the it's pulling about an amp, so about 40. Well, I'm going to just turn this down while I'm talking. So the problem is with the other circuit is that there is a 12 volt regulator that's on the same supply rail as the actual primary circuit. So you can only go up so far, and it's using a smaller MOSFET as well for the primary drive. So I figured I'd beef this up. I have my own circuit to kind of play with. Yeah, even that 7 volts. That's pretty good. That's not bad for it to light that up. I think that's pretty decent. However, it could be that there's some RF feedback, because this is coming from the coil, the secondary coil, this little wire here going down the crocodile clip. So that could be the case. But anyway, so now that I have these separated, basically, I can crank this up even a little bit more. I just don't want to damage the coil if I can help it. I don't think it's going to. That's about 30 volts. Not bad. Not bad. Just want to turn this down, just check the MOSFET. Not bad. I mean, it's warm, but it's not bad. Like a bit of interrupter on there, which I plan on building next. Just a simple little 5.5 deal. 555. I think I already have one that I could use, so I can throw that on there. But yeah, and I can play with this. I'm just gonna have that on the back burner for right now. The mini vacuum tube set up over there. It's cool. It's fun. It's really frustrating having that fuse blowing all the time. It's kind of really picky, and I figured I'd do this. It took me a while to get everything kind of figured out. I'm just kind of checking everything. It was slightly warm. Those are medium-sized output transistors right here. as you can see. I think it's the BD441 and 442, so they're complementary to each other. You can probably get away with using smaller ones, but I kind of went with what the circuit is. And yeah, basically you have your this potentiometer. There's two resistors down here on pins 11 and 12, and a capacitor between 6 and 7, which dictates what frequency you have. And yeah, it's about a 300 kilohertz range that you can have. But there's a lot more to do with this this IC. This is just kind of something to kind of play with and have fun with, because I can actually run this coil. Actually, didn't really get warm. Last time I ran this on the normal one over there, it got pretty warm. Yeah, it's pretty cool. I like it. So I'm going to carry on with this and play around with it some more. So yeah, I'll catch you guys in the next video. Cheers, guys.